Screws and nuts seem to have been with us forever. There are many different types for their various applications. If we try to lift a heavy vehicle, say, 2 tons, to a height of 3 meters, we will have to exert a force of at least 2 tons to be able to lift it off the ground. However, if instead of raising it vertically we roll it up a ramp, we will increase the distance of travel, but we will have to use less effort. Let's say about 200 kilograms to lift it 3 meters. If we move away a little, we can show a ramp closer to the horizontal, with which the effort required can be as little as 50 kilograms to raise the vehicle 3 meters. This ramp is called an inclined plane. Some centuries ago, someone had the happy idea of wrapping the ramp around a wooden cylinder, and the result was the first screw. And each screw had its own exclusive nut, since it was very difficult to make 2 identical screws. Therefore, they had to be kept together until put to use. In any case, the basic parts of a screw were at least 3: head, thread and of course, the nut. Some screws did not have the thread run all the way to the head, but rather had a neck, which saved the work of making long threads. When a screw and a nut are used to join, for example, 2 metal plates, metal discs are added to reinforce the joint. They are called washers. The nut can be omitted if the lower plate has a threaded hole, so the screw can use it as a nut. The hole of the upper plate may be left unthreaded so as not to interfere with the fine tightening of the joint. In cases where a screw is to be fixed in a thin metal sheet, self-tapping screws can be used, which act as a tool and create a thread in the sheet itself. If the screw is to be driven into wood, the screw itself can be used to make the hole, and thus you don't have to drill or tap the wood. On the other hand, the washers can be flat or lock washers, which have a spring action that holds the screw and prevents it from loosening due to vibration or some other force. Some of the various shaped screw heads are hex, square, spherical, conical, Allen type, and Phillips. The bottom row shows the most common nut shapes: hex, square, self-locking, by means of a nylon disc that prevents the nut from turning and loosening, and finally the wing nut, which can be tightened or loosened by hand. It is worth mentioning that the screws not only serve to put parts together, but to devise adjustment mechanisms for milling machines, using square threaded screws which can become part of the machines. Square threaded screws are also used in building several very common tools, such as the vise and the C-clamp, to hold parts steady while working on them. Similarly, an eye-bolt can hold an object hanging on the wall, and a turnbuckle can stretch cables, all of them using the same principle. Another important characteristic of screws, in addition to their diameter and length, is the number of threads per inch in the English system, or their dimensions in metric units. There are some very interesting gauges, called thread counters, with which you can quickly know the pitch of the thread. They are sort of combs that must match the valleys and crests of the screw you are trying to identify. When compared against the correct comb, the number of threads stamped on the thread counter can be read. In this case we have an 8 threads per inch screw. There are screws with different thread pitch depending on the measuring system used in each country. As we could see, screws are very useful, not only to hold together the components of a device, but to make different types of tools and machinery. I hope this video has been useful to you. Thanks for watching and please subscribe to my channel.